Okay, can you see which of my screens are you seeing right now?
Yeah, we see the
See the presentation?
the presentation, right?
An empty.
Yeah.
Okay,
Yes.
sure. Okay, then I will start.
Yeah, sure. Go ahead.
Well, as Maddie just said, I'm going to talk about security on cloud. This is like our research that some folks did to basically it's revisit which are the security concerns that at that moment in time people had, mostly the companies, because well, I will explain more on that later, but it's more focused on why companies are not moving to cloud. So, okay. So as you know, we have these different kind of services on cloud. The first one is the traditional IT, which the customer manage everything. And based on the level that you have for the service, the things that the customer have to manage decreases, so they can focus more on business logic or some other stuff. And they delegate all the system administration to someone else, a third party. So is my screen getting updated? I am having some troubles with my second screen. Probably what I will do is just show, let me stop sharing, because it looks like this thing, it's not working as expected. Share screen. Okay. Okay. Or, well, first of all, were you able to see the tables, or it was not getting updated?
I saw the tables. I had the chance to review them, but I saw the tables.
But they were there, right? So
Yeah.
probably I will continue there. My second screen is not showing it in real life, but it looks like it says that everything is fine. So let's continue that way. Okay. So we have all this gray area, and some people call it cloud, but for most people, this is what we could call, let me close this one. We could call computer sorcery, right? We don't know what the hell's going on here, but it is working for us, right? So because folks are not able to know how the security is handled based on the last Salem trials, let's call it that way, they decided that this is sorcery for us and we won't go to cloud because it is, we don't trust the security that they have. So this is based on a paper that was published, which is the State of Enterprise Software. And it says that 74% of the companies do not want to switch to cloud. This is from 2010. So probably the numbers are bigger right now. This could have changed. I don't have the real numbers, but this is the main idea of the paper. So the concern that it is being raised here is that depending on the layer that you want to have, the security will be higher or lower, but well, the flexibility will be higher, but at the cost of security. So for example, if you just want to rent a VM, you need to take care of workflow, what is the name of this thing? Checking all the requests, the work balancing, and a lot of stuff. So this is the reason why the companies do not want to move to cloud. And this is an interesting thing, I think, in my opinion, because not all the applications need this level of security. When you are in a startup, in a small company, probably you just want to focus your resources on the business logic and not on the security. You want to take the risk to delegate that kind of stuff. But for really big companies where they have the resources to do this kind of stuff, they don't want to take this kind of risks. So, okay. So which is the concern here?
May I interrupt a little bit there in the previous slide? Just to clarify. So you mean, like, for example, software as a service has more security than platform as a service?
No, no, the most insecure one is the one in red. That is the reason. It's like a semaphore.
Okay, so it's not
So
like SaaS has the least security, highest flexibility.
But allows you to have more flexibility because you don't. Well, actually, probably the flexibility. It's not the word. It's more like easy to use, right? It's easier to developers to use.
So SaaS has more flexibility and least security than infrastructure as a service.
Yeah, and the reason is because with every layer that you have, you are carrying over the security concerns of the previous platform because you are on the top of the previous one. At the end, you still have a VM, you still have probably your database. It's in this cloud. So I mean, you are carrying over the flows of the previous services because you are on top of it. So okay. Can I continue, Madi? Or
Sure. Yeah, of course.
Okay. So what is the concern here? Let's say that the customer provides a database. Usually these databases are segmented. For example, in the case of Oracle database, they have something called PDBs, pluggable database, that it's a small database that should not be able to be seen by the other database that coexist here. So they have like a major engine, and this one it's shared across the database. So it's shared across the customers. So for example, Office Depot could be using one database, Walmart another one, Target another one. They are different databases for them, but in the cloud side, it is the same one. There have been some issues, for example, that someone that it's not really, it's not doing all the security compliance. It's attacked by a hacker, and by that attack, they are able to jump into a bigger customer, because sometimes those restrictions are not well implemented. It can happen. It's part of the concerns that the customers are raising about cloud, right? And they are being handled over the time, but it's still work in progress. And the other thing is, because you want to have high availability, you are replicating this database. So you will have several point of failures. If one database is not well configured, then the attacker could go by that one, right? So this is like the main concern for customers. The main concern, based on like a summary of the paper, is the resources are shared. So let me continue. Okay, so this is a summary of which are the different layers that are involved here. Actually, this one explained very well what I just said. SaaS, it's over platform as a service, and platform as a service is in infrastructure as a service. So in each layer, the concerns, you are adding concerns to each layer. That is the main problem here. I'm going to explain a little bit on each one later on. But the thing here is that, as you can see, it says tenant 1, tenant 2. We have two different customers sharing resources. So the first one is data security. That could be a database itself, or it could be more like an object storage option There are a lot of different ways to attack them. Some of the examples that the paper gives is, for example, command injection and SQL injection. When you don't validate your inputs, it's possible that you are executing a non-expected command that will impact in your tables, for example, or it could elevate permissions, or there are a lot of examples, right? But the thing here is that if you don't validate your inputs, you could have troubles. There is a well, I'm not going to elaborate a lot on this one because it will take a lot of time and it's part of another topic, but I would, the idea here is that there are really well documented ways to handle this kind of, to attack this kind of services. Actually, most of these are also valid on premise, right? If they are not in cloud, but the site is exposed to the internet, you have the same problems. Okay, now the next one is network security. Most of it's handled by well-defined public algorithms to handle this, which is the SSL certificates and TTL, but it covers most of the way that you, it also has its vulnerabilities. It is not well done. So in the right side, we have most of them, right? Someone could join the network and silently, and that one is very common, right? Once that you are on the network, you are just spying what is going on here, and you wait until you have enough information to do your final attack. Session management and insecure SSL, right? The other one is, for example, the data locality, which means there are some restriction in some kind of data, like for example, HIPAA data, which is the healthcare information for US citizens. That one is really, there is a set of restrictions related to this one. Not everyone can handle it, and they need, it has a lot of restrictions on it, and it could give you a lot of troubles if you don't do it in the right way. It's high level information. So that information cannot leave the country, and sometimes the customer cannot decide where that information is stored. Like, for example, let's say if you are not you are Spotify, or, well, I don't know, Facebook. Let's say that you are Facebook, and you are renting AWS, which is the service that they are using right now. You rent it for when you have a new customer, a new user. They cannot decide what to do with that, how that information is handled. That is handled by the provider, which is in this case Facebook. So when you have third parties involved, this concern increases. The other one is data integrity. In database, is really well defined. It must be ACID, which means that you will have consistency. You will guarantee that the operations are happening in the right way. But in the case of APIs, you don't have any control on that. There are a few options to handle it, but not all the providers are allowing, or they haven't implemented this kind of options. So that integrity is another problem. Data segregation, which is what I just explained related to the Oracle database, for example, which you have a main database, and inside you have small databases. If they are not segregated in the right way, it could lead to issues. For example, let's say that the cloud provider exposes these pluggable databases, but internally they are doing all the operations on the main database. If someone attacks that process, it could impact, or it could have access to everything on the database. It doesn't matter the restriction. So you need to define really well, you need to design all your services to be multi-tenant and restricted to everyone that is sharing this resource. this is the same case that applies for virtualization vulnerabilities that I think that we discussed a few papers back, which is a container could access to the memory of the system and spoof what is going on the other services, right? Steal some information, and also apply for data breaches. Breaches. If one is attacked, it should not impact the other ones. If a customer is not handling their information in the right way, it should not impact everyone else. Okay, I think, and as an additional comment here, I was on a meeting related to security a few days ago, and it is pretty common that when you have a shared resource, it's like the gold mine for the attacker. It's a way where you can, once that you are there, you can jump to several places. So it's like it's really important. It's where the attacker will focus mostly. Data access, which is who can, well, basically the paper says that when you fire a collaborator, let's say, if you have several cloud providers, you need to remove the access on each one. And that can be really tricky, can take more time than expected, and you lost control of that. You lost control on that. For example, just to give an example that comes into my mind, in my girlfriend's company, they fired a fault. They removed all the access, and they inform the provider that gives all the phone and messaging service that they should remove the permissions, and they didn't do that on time. So this fault, still having access, started to send hate mails to all the customers and cause a lot of troubles. And that is because you spread those services and you don't have control when the deletion or the adding will happen. Web application security. The thing is that if you have a web application, it is on the internet and it is accessible worldwide. So this is the main problem here. Backups. You need to guarantee that the system will be resilient. If something happens, there is a tsunami, meteorite comes into the site and you lost everything, customer can still continue working after restoring all these backups. But the thing is that the provider needs to take care of handling all this backup in the right way. If they are not encrypted, for example, and someone hacks the file storage service, then they have access to all the data. So they could restore that database or that information and have all the information of the customers or whatever it's stored on those tables. So that is another problem. Identity manager, which is who can access the system. It's top priority. Not all the not all the people can access the same services. So there are a few topics here. The first one is the pure identity paradigm, which is just knowing that someone is there, that that user is not related to anything. The other one is the user access, where you manually provide, well, that is what I understand. You manually provide access per user. And the service paradigm is, for example, based on roles. So if this person is just talking about database, which is the thing that I have more experience at, is you give permission to someone to take the backups, someone else have access to the information of the database, and someone else is able to create tables, new table spaces, and do that kind of stuff. And on the right side, we have the independent IDC stack, which is every time that you need to access a new service, you need to create a new set of credentials, and it's very hard to remember. The other one is credential synchronization, where the customer provides a way to sync up this information with the software as a service provider. So you need to work close to the provider to implement this. And now, because that information is replicated, you have 2 points of failures. And the other one is federated IDM. The way that I understand this one is there is a one source of truth. Like, for example, when you want to access any page, now there is a new option that says login with Facebook or with Google. Google is handling who can access. So for everything, you need to check with them, and then if they agree, you can continue. This one is more complex to implement. You need to be really big, so people will be interested in grabbing your identity manager, to say it that way. So it has some troubles related to this. It's more complex to implement, but this way the user only needs to remember one password. Okay. Now, talking about security analysis, there has been several researches related to this. For example, in 2008, Verizon did some research, and it said that most of the attacks happen into the application and the service layer, which in this case is software as a service. It's just something to keep in mind, right? The most attacked platform, service is software as a service. So if you don't have control on that security, it could lead to problems. The second one is attacking the platform. Basically, you access the operating system where the application is running, or probably the layer that it's taking care of the virtualization. Exploit known vulnerabilities, which means that the provider never patched their stack, so they lead to vulnerabilities. There one is known vulnerabilities, and sometimes in the code there are backdoors.
Now, I have a question about that.
Yes.
Yeah, you say that software as a service is the most used, right? It's the most vulnerable.
Most attacked.
Yeah.
The most
but also the most vulnerable because it has less security, right? So yeah. So
yes.
Where do you think it's infrastructure as a service? They don't attack the infrastructure?
They also attack the infrastructure, but as I explained, when you have all these layers, they can attack the infrastructure, they can attack the platform, they can attack the software. So you have multiple failure points. So it's not that it won't happen, it's just that you don't have control on how to mitigate this. Everything is on provider side.
Okay, thank you.
Thank you. Okay, there is another organization which is Open Web Application. Sorry, I forgot the other two letters, but project, the PS project, as I will tell you later. At that moment in time, they listed, usually this is the thing that this organization do. They collect like the top priorities, well, the top risks on security every N years. So at that moment in time, in 2009, they mentioned all of this, which if you review them, they are vulnerabilities that you also have in any web application, right? So it's not cloud specific, but whatever impacts internet, whatever whatever attacks the internet, also it's a risk for cloud. Actually, that is the next point. Internet risk or cloud risk, right? So this year they are rewriting these points. It is still work in progress. There is a Git page with all these points, but if you open each one, everything says to be defined. It's empty. They have like the headers wherever they want to explain, but this is still work in progress. So if you want to review it, this one is public. And in my opinion, based on what I saw, most of these issues are like containers of the previous ones. For example, everything related to when I told you. Everything encryption can be mapped into insecure secret storage. The injection flows we also have injection flows on the other side, but it is covering more stuff, not only SQL and OS, it is covering everything related to all the layers. Most of this information can be mapped into something else. Not sure if, for example, the logging stuff was in the previous one, I don't think so. But it's this new set of concerns is it has like a cloud word way to explain it, or cloud wording, right? So in almost 13 years, the concerns are still similar. They are just evolving and adapting to whatever it's cloud today. So if there's nothing else that you would like to discuss on this one, I will continue. Well, wherever it's a cloud, a risk on the internet, it's a risk for cloud. And the paper also mentions some possible solutions for this. They suggest like a security framework, which is, I think that frameworks are always a good thing because they force you to implement good practices. My only question is, if this framework has a vulnerability, then you are not solving anything. So probably you are reducing. So it's still a good option, but I don't know. I have my doubts. The other option is network filtering. Wherever it's coming from the internet, we are following up what's going on and we detect a normal behavior so we can block it. The other one is having good practices. Basically, that is what it says. You must have good practices in the way that you implemented your stack. So you need to have a good identity service. You need to patch everything, and you need to remove the leftovers. If you have a service that you are not using, remove it from the stack because it could be the gateway to for an attacker. The other one is a private cloud, which is pretty popular for some customers, which this is one of the points where I say that this paper is not focused for the startups. It's more like huge companies. They are the only ones that that have the resources to have their own private cloud. For the smaller companies, we need to use cloud most of the time. So yeah, for example, I had here an image from Silicon Valley TV show, which says, think inside the box. Basically, we will sell you a box that will do everything for you. Please don't share everything. Don't bring this outside it. And the last one is security as a service, which the author mentions that based on the criticality of the project, you could provide one or another security. I'm not sure how this will work. Probably it is, you pay more for more security because you are using more resources. But for most of the time, I'm not sure if everyone it's okay to. The thing here is that the security of your system, well, your system is as strong as your weaker module, right? In a chain, you know there is this this popular refrain that says that a chain is as strong as the weakest of the eslabon. So I think that is similar. If you want to ignore this security, you are just accepting that some attack will happen, right? But also the money comes into picture. So I don't know how in real life this will be handled. And just some additional thoughts from my side for the end. Well, the first one I just explained, right? A shared resource, it's the bridge to all the customers. There are some way to audit the code right now. There is a tool called Fortify that will do some static analysis and tell you if you have some security flaws, some bad practice. The thing here is that it will tell the developer if they want how safe the application is, but this kind of audit, you cannot share it to anyone, because once that you publish that kind of information, you are telling the world where the flaws are. And also spending time to fix security issues to 100%, it's similar to the unit test coverage. If you want to reduce it to 0%, you have to spend a lot of time and resources, and it's possible that if your design won't allow you to fix everything, so sometimes you need to accept, probably just remove the critical ones and accept them. And yeah, I think that is everything that I have from my side. Is there any question from anyone? Thanks a lot for your time.
Thanks a lot, Oscar. We can start the discussion part, led by, forgot.
Laza.
Jose Laza.
Yeah, Jose Antonio Laza.
Yeah, me. We have been discussing on in the
Yeah.
chat something. Well, right now there's a quick question from Alejandro. Christian, would you like to say it?
Sure, let me just open the chat.
Based on your
Uh,
research, how much your perspective of security has changed, and do you trust more or less in the service you use?
I think that security has become something really important in the last years. So I think that, as I said before, it will depend on who I am, right? For example, if I am a huge customer, probably I will wait a little bit because I have the resources to have something else that will work for me at the cost of all this elasticity, right? And at all the advantages that we know that cloud provides. If I am like a startup, that if I don't publish my code, if I don't go into market in the next month, I cannot spend this amount of time trying to fix security when everything else is still in progress. I need to decide where I'm going to focus. For those cases, I think that I would delegate the security to those services. They are the provider. It's not like the cloud provider doesn't have security. They have, and they spent a lot of money trying to have that level of security. It's just that some customers do not want to go blindly with this kind of stuff. For someone small, I think that it's a good option, because if I don't delegate the security to someone else, probably I won't take care of it from my side. Or probably I will do it in several releases. And I mean, you need to balance all that stuff. That is my opinion. I'm not sure if someone else would like to add or have a different opinion on that topic.
Yeah, I think also the same with you. Like, at least at Oracle, I know they provide like cloud at customer. So basically, it's Oracle provides the service and all the cloud and put it on the customer side. So they will have access to the servers and rack, but it will be like managed by Oracle. So they know that all the information is not leaving their server and their like buildings.
Mm-hmm. They
so
feel more comfortable in that. Mm-hmm.
Yeah, that's a nice product that Oracle has, and that way I think more like big companies are getting into cloud?
And that
Right.
one, it's really, so I just want to add something. It's really interesting because Oracle is still handling the software, the virtualization, a lot of stuff, but now the hardware, some hardware at network stuff, it's handled by the customer. So the customer is, based on this table, you will see it like the other way around, where they don't have access to the software, but everything else, they own it. So it's interesting the way that they provide that service. Pedro, were
So-
you?
Yeah, so who do you think is the provider with the best security?
I don't have that information.
No,
If I
so
will,
who do you think?
yeah, if I would, if I have to say a name, probably it's Amazon, just because of the amount of time and resources that, the amount of time that they have been on the market and the amount of resources.
Yeah, but don't
That
you
is
think
my-
that having like more stuff means like they have like less security because, well, they have more things that they need to take care of. Like, for example, well, the amount of data that they have is not compared with someone like with something like Oracle, right?
More people will be willing to hack them rather than attack smaller companies.
Mm. That is a good point.
I mean, I do think that, I mean, if you even go into the reports that we were checking, is that most of the top risk is, I mean, I do think that it's still on the end of tons of injection flaws. I mean, I have worked in a couple of startups, and the time that we have been threatened and attacked, it has been mostly because of our fault. And it was because, as you were saying, we were just moving too fast, and sometimes we were just like, okay, just leave this whatever monitoring open for today, and tomorrow we'll continue working on it because we don't have people. And then the other day we had all the indexes resetted. We were even experiencing injection flaws, and yeah, I mean that's what they really look forward for. And I do think that, for example, AWS may, if you go and look for statistics, you will probably find that most of attacks are to AWS servers, maybe. But I think that is because they already know how the things look like, because it's like the most common one, right? I mean, for example, we used to have this technology that was API gateways from AWS. That is what you usually use to have like a REST API in a serverless way. we just like forgot to set up some of the integration part at the very beginning, and it allowed for scripts to pass through all the way into like our lambdas. So yeah, I mean, that was like, I mean, when we researched about that, it was a common threat. So I don't know.
Yeah, but I mean, I feel like saying that AWS might not be as secure because a lot of people attack it is a relatively poor argument. I mean, yeah, like people attack it because a lot of services are there, but the counter argument is they actually do enforce a lot of security, right? Like they do worry a lot about security. So the other option would be, let me put everything on my little machine, which has an outdated version of the OS and uses outdated libraries, and let me handle security myself. Arguably, if someone was attacking your service mounted in your infra, will probably have an easier time than if it's mounted on AWS. So yeah, AWS like statistically might be more attacked just because it's bigger, but that doesn't make it more insecure.
And also, probably tools are already there and we are not using them, right? For example, I'm thinking in my house network, I wanted to access my house from the internet. I opened a port. I never took care, because the restriction is there, right? A way to block any access from outside the network. But when I realized, I decided that it's easier for me just remove that block and let everything go. You will see in my computer a lot of failed SSH calls, because there are computers running all over the world looking for who didn't do their homework in the right way, you know? Mm-hmm. So the tools are there, but sometimes because it is easier for us, if you remove the restrictions, you could develop in a faster way, but you are also simplifying the attacker's work, right? So
actually, that's why I questioned that chart you were showing. So apart from the traditional setup that you imagine, you have everything in your private infrastructure. And as Ricardo highlighted, if you connect that to the network, it's definitely insecure, unless you have it totally disconnected from the network, so you can keep it secure to some extent. But your chart was showing the more control the cloud company has, the least securities. And that
you can,
is
Mhm.
that is a little bit,
go on, sorry.
for me, it's still confusing. I mean, there was a good argument in the chat, but still I'm not convinced, honestly. I mean, the more control we pass to them, the least secure we get. I can't get that. I mean, I can't comprehend that totally.
Yeah, the thing here is that if you are a big business and you have a security team, you will be able to tweak everything to make it work the way that you will like. So if you have the resources, you can do it even better in your site. The thing here is that because you are not able to tune the system, most of the companies are out of the game. Probably I will.
I think now that I think I misunderstood the figure actually. You were saying SaaS is the least secure. So I mean, when it comes to the cloud, the least control you get to the cloud company, the least secure you are. You had SaaS, then you had platform as a service, infrastructure as a service.
Yeah, how to explain it? The thing here is that let's say that you have that an Amazon vulnerability was published at some moment, and that means that if you have there is a vulnerability on the top of your stack or a vulnerability on the middle of the stack, there are several ways to attack you. And while you are reducing that, you are just restricting that kind of options to the attackers. But if you don't implement security, of course, it will never, it won't be secure at any level. It's just if you have the resources to do it by yourself, probably you can do a better work, but this is not for everyone.
Yeah, I think what Oscar is trying to say, like if there's a vulnerability in infrastructure as a service, then no matter what, if you pay for a software as a service, if you make it really, really secure, if there's a vulnerability in the infrastructure as a service, they can attack you, right? Because it's not in your plate.
Yeah, I mean, I guess the argument is the higher up you're in the stack, you have the union of all the vulnerabilities below you. But I mean, I guess that would arguably be true of most in-prem deployments as well, unless you're like Oracle and you're paranoid of open source and you rewrite every single line of code of every single thing that exists. In that case, maybe you can say, yeah, like maybe Linux has this known vulnerability, but I don't use it. So like maybe in that sense, that is what Oscar is saying. Like if you're a big company, maybe you are not vulnerable to the same like security risks as the rest of the world, just by virtue of the fact that you're like doing things your own way, right? Like, so maybe there are some known bugs in Linux that Oracle's Red Hat Linux does not suffer, right? And maybe they are not publishing, like that OS is not like openly available, right? Like maybe it's like a top secret OS that Oracle uses in its own infrastructure. So in that sense, using a public cloud with known vulnerabilities, you carry over all of the risks from all the layers below you, right? So I guess that's kind of the argument.
Yeah, thank you. Yeah, thanks a lot for explaining it in that way.
Cool.
Good. One of my questions is, what do you think about security as a service? The paper talks about it, like if it should be done like if you're a big company and you need lots of security, then I will charge you more and will give you better security. And if you're a small company, then I will not charge you as much. What do you think, like this business?
No, I think that
Logic.
it's more like, for example, you will have a more robust workload balancer, because I mean, at the end, some of all these how to say it, walls that you put between the attacker and you, it's usually another resource that will help you to do that kind of stuff, and that resource has an electricity bill at the end, right? So I think that we will provide you all this. There are some resources that are how to say it, yeah, I think that it will expose it like new resources. Some of them will be virtual resources, like for example, this database version that has better encryption you have to pay more, but at the end it is running on the same machine and everything is the same. And some other will be bare metal stuff that they will add, and it has an additional cost. So probably based on if you want to check everything on the box and have all these walls enabled, you need to pay for that, right? That is the way that I understood it, but in the paper, it just talk about that for a few lines. The paper seems like history of art, a resume of all whatever is going on here to justify the next work, which is this security as a service.
I think that security as a service will be companies shooting themselves in the foot, because essentially they are advertising, oh, if you put your service here, you're not as secure, and these are the known vulnerabilities. I think security is a given, and like the cloud provider that proves that is the most secure will be the biggest winner, right? Like, I mean, modulo vendor locking and whatever you want, but if you know for a fact that like for the same price between cloud A and cloud B, you get better security in B, and you need to pay higher price in A to get the same level of security of B. Like, security is so important that like you cannot afford to not pay it. So if cloud vendors start charging extra just to give you security, I think that will be like, that will reflect really poorly on them, and that would like make people go away from that provider.
Good. Anyone else has any opinion of this security as a service? Guess not. Then, which is the biggest security flaw that you know from these cloud services or cloud providers? I put some links there, like one really big security flaw from OCI was that it allowed to control basically the machine, right, from your OCI connection environment. You could go to the hypervisor and will be root, I guess, from that. So that's a really big security flaw. Have you heard of another security flaws like these ones? Or I searched for Amazon, and I, as Paul said, much of their issues, and from the statistics that Oscar's shown, most of the issues are misconfigured issues. But then Amazon should give you like this almost like foolproof, right? They should give you the least privileges, so they cannot escalate those privileges. No.
So actually, they are already doing that, because, like, for example, the gateways also, like, for example, they had access before to everything, and now it's the opposite. You have non-access, and you have to specifically give access to certain endpoints, for example, or open ports or whatever. And also, for example, the CDK, when you start developing on CDK, before you have to create like different type of roles. So different, how you say? So different services can access other services and things like that. And now CDK provide, if you connect two of them, they provide their role creation. So only that type of role can access the service. So actually they are already doing that like nowadays.
Which is a good idea, right? To put security first.
Yeah. For example, that's another reason that I think that, as Maddie mentioned, that SaaS is more secure, mainly because, for example, a lot of those things, new developers, or when you are start building, let's say, a startup company, you don't have that knowledge, right? And also, or if you are a medium-sized company, let's say, and you are probably you are having a smaller security team or infrastructure team that can handle the things, rather than like a big company like Amazon that has experience, like has multiple attacks probably every day and things like that, and they are constantly upgrading things, right? Another one is that, for example, if one library, for example, it's how you say, somebody finds out that a library that is being used has a vulnerability, like AWS, well, Amazon has like 24 hours people working there, developers, and can fix the issue in seconds rather than in your company, right? Probably they are going to call you while you turn on the computer and blah, 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 right? Well, that's like comparing, like, let's say, medium size or small companies versus like a big monster like Amazon, right? Or Google or Microsoft.
I mean, back in where I used to work, we started using AWS IoT Core. And we fortunately didn't have this issue, but they told us about this one, that basically since our like fog devices, you could say, were not fully protected. And these were the ones that were pushing like the IoT related information into the cloud. There were some cases in which people were able to get into that node and start pushing like wrong information. I mean, it's like kind of a Byzantine failure, you could think, right? Because it starts behaving in a way, I mean, it doesn't seem to misbehave. It is just pushing in like failed data. And I mean, for us, it wasn't that big of a deal, but I guess that for some system that do rely a lot on local automations or even strong decisioning, can be like a game changer. So yeah, I mean, but at the end, it wasn't like AWS end, right? We were already putting like the permissions into the end devices.
Okay, thank you, everyone. I think we can wrap this up because so to have enough time for the other two presentations. Thank you so much, Oscar, Jose Antonio, Ricardo, for and everyone else for this. I mean, who contributed, who discussed, asked questions, answered. So we can have I don't know, 5 minutes break. So we come back 7:38. Okay. And we continue with the second presentation.
Can you see my screen?
Yes.
Okay. Hey everyone. So I'm going to talk about this paper, analysis of security issues for cloud computing. So the contents are this: introduction, results review, most important security aspects, and countermeasures. So first, the introduction. I'm going to talk about how the research was conducted. What the researchers wanted to understand was what is the cloud computing security at that point, and they also wanted to understand what were the security vulnerabilities and threats most important in cloud computing at that point, and how to handle them. So what they did, what they researched was, well, they took different papers from different sources in English, like ScienceDirect, ACM, Digital Library, School Google, etc. And they include some other papers like from important authors, journals, and other factors. And well, they use some keywords like security, cloud computing security, security in SPI model, etc. So they got a list of 120 papers, and from those papers, they just considered works that included like vulnerabilities, threats, and countermeasures. Right? Those works had to talk about those three things in order to consider them in their work. So the final list that they considered were just 15 works, and yeah, those were the ones evaluated. So they focus a lot in the SPI model, which is SAS, PAS, and ES. And what they got was a list of security issues applied to those security models. So, as you may know, as we've seen like a lot of times, right? We have SAS, PAS, and ES, and software. SAS, for example, is software as a service, right? The cloud provider basically gives you access to their software, so users can use it, and that software runs on top of cloud infrastructure. The platform as a service is cloud provider gives you the tools and frameworks so that you can, developers can build applications on top of that. And infrastructure as a service, they provide you compute resources, storage, networks, and you can do whatever you need to do with them. Okay, so they talk about the security in each of those three models, right? Basically, in SaaS applications, the security burden is less for the customer, but you have less control over the resources as well, right? You can just use the software and that's it. In the next model, and the PaaS model, then you have more control over resources, but it also implies that you need to be more concerned with security. And in the last model, yes, you have all the control over the resources, but you need to be more careful with thinking about security. And also, one of the things that we were discussing from the previous presentation was that higher up in the model, you have you can have issues if there is vulnerabilities in PaaS and ES, right? If there is a vulnerability in ES, then probably the software in SaaS is going to may be affected. So this is something that the researchers also like consider in this, in their work. So I'm going to talk about some of the security issues that they found. Again, this is divided by SaaS, PaaS, and ES. So for SaaS security issues, basically the first is application security, right? This is just if you flows in the web application may create vulnerabilities. So you need to be how to say it? There are issues in the way that there could be vulnerabilities in the way you build those applications, those web applications. So they provide, they have a list of vulnerabilities. For example, in the year 2010, the first three vulnerabilities were like injection, cross-site scripting, and broken authentication. And then, this is a paper from 2009. So now the vulnerabilities have changed, right? I have the list for 2021. Now the vulnerabilities are broken access control, cryptographic failures, and injection. And I think in the previous presentation, we had, in the previous presentation, we have the vulnerabilities for 2022. Now, other security concern is the multi-tenancy. SaaS applications can be grouped in maturity models, which what this means is that the SaaS application can be in level 1, 2, 3, or 4, depending on like the level of maturity that they have. Level 1 means that each customer has its own custom code of the SaaS software, and that software only serves to one single customer or tenant. In these kind of levels, the security issue is not, well, the security concern is not that high, because, well, you have custom code and you are just serving, that code is just serving to one customer. In the level 2, we have single code, so there is no custom code anymore. And every customer has like its own application running in a machine. So it is all isolated by customer. In the level 3, we have single code as well, but now this code is serving multiple customers where they can customize some options for their applications. And in the last one, it is scalable multi-tenant, which is the same than level 3, but now with scalability taken into consideration. So other issue is data security. Provider is responsible for securing the data while being processed or stored. They also have the burden of backups in case of disaster. Also the third-party services, they are also a concern because the customer doesn't know if the third-party services are like secure. So that also has some concern issues. And in the case of accessibility, since now all mobile devices can access to basically every SaaS applications, it also raises some concerns in security, right? Probably the device from that is accessing some SaaS applications is not that secure. It has some software that malicious software installed, and it can cause some issues. In the case of PaaS, we have just 3. Third-party relationships is basically what is similar to the SaaS security from backups, third-party backups, where you need to trust third-party software, right? You can install third-party software in the PaaS application so that you don't have to create it by yourself. But again, this also inherits all the security issues from this third-party software. Development lifecycle means that you have to adapt to the speed at which the software is developed in cloud. So it means that you need to think in flexibility and have a robust software so that every change that you make, well, you are not going to introduce bugs or vulnerabilities. So it has to be tested, and yeah, you need to have a different mindset in cloud. Also, they mentioned that PaaS needs to be upgraded frequently. This is an old paper, so yeah, probably that was true before. It was almost 9 years ago from this paper, so yeah, I'm not sure about that statement, but yeah, that's what they said, right? Underlying infrastructure security, well, this is how do you ensure that the software and frameworks and tools that you are using, they are secure, right? You need to trust in the cloud provider. You need to trust in the security provided by the cloud provider. And the data security also depends on provider, right? How is that processed, transferred, or stored? Yeah, security issues. Okay, this is the interesting piece because it brings a lot of security concerns, I think, because in EAS you have like all the control, right, over all the resources, network, storage, computing. And now, well, one of the issues that they raised was virtualization, right? That now you can have, you can create, copy, share, migrate, and do a lot of things with virtualizations, with virtual machines. And all of each of these creates security concerns. And I'm going to talk a bit more about like the concerns for virtualization later. So yeah. Virtual machine monitor. So the problem with virtual machine monitor is that it, or hypervisor, it like takes care of all the virtual machines in a computer, right? So if the virtual machine is virtual machine monitor is compromised, then probably all the virtual machines may be compromised as well. What else? So one of the issues with virtualization is that they can be migrated, copied. So it may how to say it? So data sorry, they might be copied or migrated. So when that virtual machine is being transferred, there can be data leakage. For example, you can copy some configuration or some passwords that you have in the original virtual machine, and you didn't want those to be like migrated or copied in the copy, right? So it brings some, it has some issues as well. One of the other things is shared resources, because virtual machines share like the physical memory. These can decrease security, right? Virtual machines can infer information about other virtual machines using covert channels, and this is a problem. Also, public VM image repository, it is also a problem because every user user in the cloud can publish VM images in the repository, and all users can all the users can use those virtual machine images. So there could be malicious users that install software in a virtual machine image and in a virtual machine and create an image from it, and then other users can download that image, and they will have this vulnerability, right? They will be installed with this probably virus or stuff like that. So they are hard to patch because they can be offline. So you don't know if the virtual machine has any issue until it is up. So this could be a problem. So we have other like virtual machines rollback. In this case, in a virtual machine, you can like patch or probably fix some configurations right? Virtual machines have the ability to roll back to previous states. So if you have already fixed some issues, but you apply a rollback to a previous state where those configurations were not fixed, or probably some accounts in that configuration are already enabled and you have previously disabled them. So this may be a problem, right? Probably you don't remember that you disable the accounts or you apply those configurations. So if you roll back to that state, you're going to have the same problem. And also the snapshots in the virtual machine rollback may be a problem, because if you have some configuration errors or other vulnerabilities and you are creating like snapshots of that, then you're going to have that problem. Virtual machine life cycle. Let me just remember about this. This was related to the one that you can download malicious virtual machines and you can have them in offline state, right? And then at some point you decide to start them again. You decide to run them. So they will be infected already or probably will have some configuration issues. And you don't know, right? Because they were like offline and then suddenly you start to use them, and then now they have issues. And now for the virtual networks, there could be cross-tenant attacks, sniffing and spoofing. So what they did, all these like security issues, what they did was just to consider some of the most important, what they consider the most important security aspects. Sorry, I thought I explained a lot of things very fast. Sorry for that. Let me stop a little bit. Do you have any questions so far? Yeah, I'm like talking very fast right now. Sorry.
In the previous slide, you were talking about, can you go back? You were talking about virtual machine lifecycle, and you mentioned that even if virtual machine is offline, it can still be vulnerable. Do you have any idea how that can happen? Or
what I understood is that it is not that you can infect an offline virtual machine, right? Because it is offline. At least I didn't follow like much information about how to do that. But what I understood this means is that if you copy a virtual machine that has malicious code or some configuration that is not like a bad configuration, and it stays in offline state, you don't know that that virtual machine is like malicious until it starts running. So when it starts running, then it is going to have the issues. And if you migrate that virtual machine, then you're going to proliferate that issue around other virtual machines. So yeah, that's what I understood about virtual machine lifecycle. Right? It is not like they can be infected while they are offline. It is just that if you have one already infected offline virtual machine and you copy or you migrate that offline virtual machine, then you're going to have issues.
yeah, got it.
Okay, any other question? No, okay. So what I was saying is that they considered the most important like security aspects and created a list of like the 7 like most important vulnerabilities for them and the 10 most important threats for them. So we're going to start with the vulnerabilities. This is what I was saying. Sorry. So this is the vulnerabilities, right? And probably some of these do not apply now because again, this was a paper from 9 years ago. So one of the vulnerabilities are insecure interfaces and APIs, unlimited allocation of resources, data-related vulnerabilities, virtual machines. Sorry, let me explain again. For insecure interfaces and APIs, well, what they found is that you need to have like strong credentials, right? All the cloud users can use the APIs. And if you have weak credentials or insufficient authorization checks, then malicious users may get those credentials by social engineering or just by brute force, right? And get access to that, to your cloud account. Then they also mentioned that APIs are still immature. So that's why I said that probably this doesn't apply now because it's been 9 years from this paper. So maybe, well, not maybe, they have improved the APIs, right? Unlimited allocation of resources. I'm not so sure about this. They said that inaccurate modeling of resources usage can lead to overbooking and over-provisioning. I think this is similar to the paper that we discussed a few weeks ago about how elasticity works. And probably this has been improved in previous years. So yeah, I think this may not be accurate today. Vulnerability in data-related vulnerabilities. So one of the issues that we have for cloud computing is that data may be stored in the same in the same disk, right? They may share the same storage, and using that information, well, some attacker may be able to access data, right? Data compliance means that you need to understand how to process and store data around based on the country, right? Probably the laws in US are not the same here in Mexico, so you need to consider every one of those aspects for data-related vulnerabilities. Incomplete data deletion means that data cannot be completely stored. You can try to recover data from hard disk drives by trying some techniques maybe. And yeah, the only way to completely remove the data is by destroying the device. Data backup done by untrusted third-party providers. Maybe, again, this is not the case, right? I think, well, I'm not sure how AWS or other cloud providers work right now. Like if they use third-party providers, I don't think so. They have their own services that provide that. So maybe that's not true now. And yeah, also data is often stored, processed, and transferred in plain text. So anyone in the network could read this data if they want. Other vulnerabilities, virtual machines, covered channels may allow virtual machines to communicate between them, right? And restricted allocation and the allocation of resources. This is related to the shared resources. Someone with enough experience and knowledge and that knows that it is sharing memory with another computer may be able to get access to the data because they know that all the data is in the same physical memory. So yeah. Uncontrolled migrations, snapshots, and rollbacks. This means that what I was saying about the VM image repository, if you have if one attacker or malicious cloud user uploads an image, a malicious VM image to the repository, and other people start using it, and then they also migrate that malicious image and create the snapshots of it or rollbacks, then those issues are going to proliferate, and that's an issue for vulnerability as well. You can know the VM location by the IP address. And virtual machine images, this is what I was saying about public repositories and that everyone can upload virtual machine images. That they are difficult, virtual machine images are difficult to patch until they are online, up and running, then you may know that something is wrong with them, but while they are just in files, then you don't know that they can have a problem. Hypervisors, complex hypervisors code. What this means is that if there is an issue in the hypervisor, it is complicated, maybe complicated to fix. So, yeah. What else? Virtual networks. Again, sharing is good, but also gives attackers more information about other machines or networks. So this is also this may be a vulnerability as well. And the next is the list of threats. I talked about some of them already in the previous, in the section number 2. For example, the one about account or service hijacking, you can get access to credentials using social engineering, or if the user has weak credentials, data scavenging. You can access data, recover data from devices if they are not destroyed properly. When you data leakage, when you migrate data, when you migrate virtual machines to a different server, they are transferred using the network, right? So at this point, attackers may be able to get some information from that in that transference. So yeah, the denial of service. Yeah, some attacker may take all the resources, and any other request is not going. Any other request is not going to be served. Customer data manipulation, SQL injection, command injection, cross-site scripting, VM escape, exploit hypervisors to take control of the underlying infrastructure. I didn't remember that very well. Okay. VM hopping, VM virtual machine gain access to another VM using hypervisor vulnerabilities, or also cover channels. They can be applied for that. Malicious VM creation, VM image containing malicious code, insecurity VM migration. If we have already one virtual machine infected and it is migrated, then that new virtual machine is going to have that malicious code, and also again that the information while the VM machine is migrated is exposed to the network, so an attacker may take some of that, may be able to read some of that information. Sniffing and spoofing virtual networks, like listening to the network, and also like pretend to be a machine that you're not. Yeah. Any questions so far? So this is the list that they came up with. And some of the countermeasures for this, at the end, they provided one like table with the threat and the vulnerability that they can exploit, that threat can exploit, and the countermeasure for that vulnerability. I think from these 7 vulnerabilities, they just didn't mention for vulnerability 2 and vulnerability 5. I don't remember. I think it is just 2, vulnerability number 2, but yeah, they provide a countermeasure for all the others. So, for example, for account of service hijacking, so they said that they provide, well, not they said that the Cloud Security Alliance is a group, and is a cloud group that created like a guidance for cloud providers, so that with best practices, right? So that they create a centralized directory, like access management, identity management, role-based access control, etc. So I think this is true now for AWS. I think they have a centralized directory, and also like they can create users and also create roles and identities that you can apply to different groups. So yeah, this is like just the list of best practices for that. And this countermeasure the account or service hijacking, which is the threat number 1. Also dynamic credentials. Well, basically what this is that you don't have a hard-coded credential, right? And I think this may be applied to the role-based access control in the AWS, where you can get like a temporal access to a different resource from a resource, right? So it is not a static password that you have in the code or anything like that. Data leakage. So in the case of data leakage, they propose fragmentation redundancy scattering, which is a way to store data in a distributed way. What they do is just break like the file in different chunks of data that don't have any value by themselves. They have to be all together so that you can have information. well, you can get some information. So what this is just they split the data in chunks, and then they apply encryption to all of these pieces, and then it is like replicated and then distributed across different storage servers, so that if an attacker is like checking the network and is trying to get information from that, it is not going to be successful, because probably it's going to read just a fragment of all that data, but not all the data. So they will need to read all the read all the pieces and also put them together and then apply well, decrypt all the pieces. So yeah. Other countermeasure is digital signatures for data leakage. So this is just using RSA. So you have one customer, well, one person, they use the public or private key depending on the scenario, and then other person uses the private or public key depending on the scenario. For example, for digital signature, you'll sign your documents with your private key and send it to a different person, and then the other person, to validate that it's you, uses your public key, and if it matches, then it means that you signed the document. So he or she knows that it was you that sent the document. And yeah, this is also one of the countermeasures to for data leakage, right? To encrypt the data and just decrypt it when it's necessary, and that the receivers knows what to do with the data. Homomorphic encryption, also this is a countermeasure for data leakage. So this was interesting. I didn't know about it. So what this is it allows you to perform computations on encrypted data without decrypting it. So the results of these computations are going to be encrypted, but they are also going to have the operation applied. So for example, you have a 5, you encrypt it, and then you applied an homomorphic operation, let's say an addition 10. The algorithm is not going to decrypt the data in order to apply the operation. It is going to apply the operation on top of the encrypted data, and then the result is going to be encrypted data as well. But then when you decrypt that new result, it's going to have it's going to give you 15. So this is what this means. It is not used now because it requires a lot of computational power. It is not, it is not like very fast. So yeah, this is the problem with homomorphic encryption. But yeah, it is cool. Encryption. Use advanced encryption. Using advanced encryption standard or SSL to store data. It may ensure that the data is going to be secure while stored or transferred. Customer data manipulation. So this is for the cases for SQL injection, cross-scripting, cross-site scripting, sorry. And what this countermeasure is to use web application scanners, which is software that scans the website looking for vulnerabilities as if it were an attacker, so that you know which are your vulnerabilities before like a real attacker knows them first. So yeah. These are just some of the providers for web application scanners: Acute-NX, NetSpark, and IndoSpace. I must apologize about this because I really wanted to understand more about Hypersafe, trusted cloud computing, and I think there is one additional that I couldn't get the paper for IEEE. But anyway, these are for VM Escape. So HyperSafe, it is just an approach to protect the virtual machines, like the memory for the virtual machines. So yeah.
Sorry, Luis, for interruption. I don't know how many slides left, but try to wrap it up so we can have enough time.
Oh, okay. Yeah, I just have, I think, three more. So, well, these are just other confirmations. HyperSafe, Trusted Cloud Computing Platform, and Trusted Virtual Data Centers. I don't have a lot of information about these three, so I will just mention them. So yeah. And the other one that I was talking a lot of, is about the virtual machine images. That it is a public repository, and everyone can like upload and download images from the repository. So Mirage is just a management system, image management system that provides security. It provides access control frameworks to VM images, and also like filters to remove unwanted information, malicious software, or other things. So if you download an image, you may be sure that it is going to be secure. For migrations, we have protection edges for live migration, VNSS, and I think that's pretty much it. Okay, and virtual network security for like sniffing and spoofing virtual networks. And yeah, I think that's pretty much it. This is the table that I was talking about, where the thread ID and the vulnerability ID, the countermeasures for each one of this. So yeah, that's pretty much it.
Okay, thank you, Luis. Let's start the discussion led by Juan Carlos.
Yeah, hi everyone. So first question, with all the threats and vulnerabilities described in the paper and in the presentation, I'm curious, do you research how strong the security of a SaaS application is and how it handles your personal data before using it and sharing personal information? Like, for example, I don't know, Gmail or Office. Yeah, I'm just curious how concerned we are about security.
I mean, you mean in terms of reading their terms and condition, or?
Yeah, those kind of things, and I don't know if they have been attacked and things like that.
I don't think anyone's going to go through this.
Okay.
We just trust, basically. I mean, a couple of days ago, I saw an infographic how long it takes for you to read terms and conditions of different companies. And I think like Instagram had almost the shortest, and Microsoft, I think, has the longest. It would take you like 7, 8, or more than 10 hours to read the terms and condition. I mean, if you're reading fast, okay. So it's basically impractical, but actually there are certain companies, there are certain organization, not company, organization, that they try to simplify this type of terms and condition. Basically, they dedicate themselves to go through these things and find those basically loopholes, weird things, and highlight those parts for the users, or simplified in infographics or stuff like that. I think one of them, if I'm not mistaken, I'll just talk, I'm not sure, but it was Who Has Your Back or something like this, a service like this. It was about privacy, what type of privacy provided by different companies. Just my 2 cents.
I was just going through Google Docs, like privacy policy. I mean, just wondering, like, for example, if you were to have something valuable there, and it says that it is stored securely in our world-class data center, and it is encrypted in transit and at rest. And well, and if you choose to access this offline, we store this info on your device. That's the only thing that they say. I mean, I thought that maybe they would say like for 10 years or something like that, but there's no time limit, it seems.
Interesting.
Okay, then next question. Can you mention any famous cloud security data breach or attack that you recall? For example, I remember that PlayStation was hacked some years ago, and due to this attack, private data of a lot of users were exposed. So I don't know if you know any famous like.
I
hacks.
remember that I got three games by free because of that.
Lucky you.
I think everyone that was on PlayStation Plus received those 3 games.
Yes.
Yeah,
Few years ago.
they just gave it to keep people happy. If that was the case, right? Yeah, I remember.
Yeah, because they interchange those games for your private information like credit card numbers and everything. I think it was a big deal. I don't have any money, so it was a big deal.
I was just reading through this article about data breaches, and they say about this CAM4, that is a adult video streaming website, had its Elasticsearch server breached, over 10 billion records that have full names, email address, chat transcripts, password hashes. Also a Yahoo one. There's also a LinkedIn one from 2021. The data associated with 700 million was posted for sale in a dark web forum on June 2021.
Yeah, actually, Jose also put a couple of links in the previous presentation.
Yeah.
Some incident in AWS and Uber and stuff like that.
I remember this like big scandal in USA where this famous like page for like matching with other people, but they were most for like married people, right? They like expose all the information about that. So I think the rate of divorces were like high in those years. Yeah, but they were exposing that.
Yeah, I read about it. Yeah, that was big. So
Okay,
just a good question. I mean, that come to my mind for Luis and everyone else. I mean, they mentioned a lot of like vulnerabilities, a lot of countermeasures. Big chunk of those vulnerabilities are network-related vulnerabilities. Not big chunk, but some of them. And some of the solutions I were thinking, it's more like a trade-off. It's not like a solution without missing anything. Like you suggesting a certain solution that going to affect you in another way. I mean, going to make you more secure, but affecting you another way. So it's not just pure gain over certain solution that you were presenting. I don't know, how do you think like that? I mean, how do you think about this? I mean, about the trade-off in general. I mean, of course, we can make things super like what one of the solutions, like the encryption. Yeah, I mean, of course, let's encrypt everything, but does it solve all the solution? I mean, is it practical really, like encrypting every data in cloud?
Well,
Well,
I guess, go on.
Yeah, I was going to say that it depends, right? Everything, it depends. But okay, some of the solutions that they propose, like they said that it added a little, or just a little of how to say, it requires just a little bit more of computing power to apply that like countermeasure that if you don't have it. So it is more like you can have like more security for a little bit more of probably delay in the communication, but it is more secure. But yeah, I think it depends in the case, right? Because for example, this like FRS countermeasure, like where all the data is encrypted and it is distributed across a lot of databases, then but you need to do the contrary steps in order to get that file, right? So it's going to add delay probably. So I guess it's depending on the case where maybe you need where that data is not accessed like very frequently. That could be one use case for that countermeasure. But if you are reading like the disk and many files, probably it is not like feasible to do it because the delay is going to be like huge, I guess. Well, you were going to say something, Rodrigo?
Yeah, I was saying that probably one of the approaches that I have heard is that we have to make data in a way impossible to be traced back. I mean, to be like, I mean, that having that amount of data, we can identify who that belongs to. I mean, because as long as we have that measures, I mean, and that they know that they have all that data, but they don't know who that belongs to, then even if it's reached, I mean, we're good to go because we don't know who that belongs to. I mean, it's like a very long shot, I guess, but I heard about that one a lot. And I don't even know how to do that, but
True. Any other questions? Points? And so if no, we can wrap this up. So to keep you up enough time for this last presentation. Thank you, Luis, and everyone else participating in the discussion. So shall we continue or you want a quick break or?
Quick break.
Quick break. Okay, so let's come back 8:32. Okay, to continue. This is just quick break for to just grab a glass of water, basically, and a stretch. That's it. So we come back in 5 minutes. So usually I put same topic. So it can be just, I know it's like we are all the presentations are about security, but that's purposely to keep it repeated as many times and also seeing different aspect of it. So that's idea. Go ahead, David.
Yes, as you mentioned, this is the same topic, security and privacy challenges in cloud computer environments. I will try to be concise. In cloud computer, without appropriate security and privacy solutions, could become a huge failure. That statement is very true. If the cloud was not secure enough, it will not be used. And one of the biggest fears for the people trying to reach for cloud computing, it's the security and privacy. This is but yes, it's the major concern about the cloud, to trust an outsider for the delicate data and processes and security and privacy. Security is a shared responsibility, and also there is a second side of the coin. In the first phase, we have the people that are afraid of the cloud computing, and the other half, it's trying to bring all the secure, all the security, leave it to the cloud provider. This is a shared responsibility. As Paul said in the chat previously, we cannot blame the provider, but our mistakes. We are going to talk about a little bit later, but it's a major topic. Security is a shared responsibility. What is cloud security? Cloud security includes a series of procedures and technologies designed to deal with external and internal threats, which put business security at risk. As the previous one, the security concerns are separated from the delivery models for the cloud. In infrastructure as a service, the cloud provider supplies a set of virtualized components as VMs and storage on which customers can build and run applications. Some issues regarding this model are trusting the VM image and hardening the host and securing inter-host communications. And other concern for platform as a service is bypassing authentication and encryptions and lack of data visibility in the cloud, because you are making an application in a platform, you not control all the platform itself, so you are limited in that way. For software as a service, some concerns are the service itself. It's composed by different providers, and those providers are not with the same level of security. So handle that information between services, is a concern. In this topic, unique security and privacy implication in cloud computing, it says that what makes cloud computer unique and powerful also raise security and privacy concerns. So we can work in fluid environments, but we carry some challenges. For example, insufficient identity, credential access, and key management, insider threats, limited cloud usage visibility. For example, in the metastructure and apply structure failures, and with control plane, some challenges are from all the side from the provider, and others are more concerning for the customer. But these are general cloud security challenges. Misconfigurations and inadequate change control, data breaches, that are data violations, abuse and nefarious use of cloud services. This is a mean use of the cloud. Insecure interfaces and APIs, like, for example, a failure in some language, or a trusting issue in some APIs. We don't have the full control of that. And account hijacking, it's kidnap the account from another user. And lack of cloud security architecture and strategy that concerns all the parts, the provider and the user. Outsourcing data and applications provide access to data, but for only certain entities. Cloud computing provides access to data, but the challenge is to ensure that the only authorized entities gain access to it. It's like, say, I am trusting you my data to use it for not other process that share me for the cost of the storage of that data, but you cannot use it for your own purposes. We have a contract, and you not can use that data that I am charging you. Extensibility and share responsibility, as I said before, is a shared responsibility and depends on the delivery model. For software as services, providers are more responsible for the security and privacy of application services. Private clouds could also demand more customized requirements. And for platform as a service, the goal is to enable developers to build their own applications on top of the platform provided. So the customers are primarily responsible for protecting the application they build and running the platforms. And in IaaS, the cloud provider must provide some basic level of protection, but all the main responsibility oversees in the customer. So I give you the hardware resources, but you are totally in charge of the security of your own software and the platform that you build. Service level agreements, SLAA, is a part of a service contract between the consumer and the provider. So it records about everything about the concerns in the consumer and the provider, like services, priorities, responsibilities, guarantees and warranties. It's necessary to measure all the parameters for not only charge for the cost of use, and also for how to manage the data and who is responsible for what activity. In this case, in security, in the SLA contract, the consumer and the provider agrees on some establishments for the usage of the data and the storage and the security matter. Also, these SLA contracts are are trying to measure, for example, for security and privacy, but not those properties, security and privacy, are not a quantitative type of data. So it's difficult to reach a point in which who has the main responsibility over security. And for those parameters, for example, let me start again. In the cloud is dynamic and necessitates continuous monitoring of the attributes, and consumer may not trust blindly on the measurements of the that are provided by the service provider. So there is a presence of a third-party mediators to measure the SLA critical service parameters and report violations. So you don't have to trust only in the cloud provider. So you have another entities that are checking the contract. It's validated. Virtualization and hypervisors. If you are if you are a cloud provider, doing this as you can save and maximize resources, but there are a necessity to ensure a strong isolation, and it might be important to associate process outputs to specific hardware components in base of the necessity. For example, data leakage. You can sign all the data stored in the cloud to get a traceability of that data. And for example, in manufacturing, you can sign all the packages of the associated with a piece of hardware that you are creating to some level, some tester of the in the line in manufacturing, and you can make a traceability of all the components and all the leakage of that pieces, because you have a traceability, but makes also in a factoring and a manufacturing way to see this, it's very easy to accomplish. But in a cloud, for example, the amount of data that you need to sign, it's a lot harder to do it. So this is an analogy, but it's always a huge difference comparing to the cloud problems. In heterogeneity, cloud providers use various hardware and software resources to build cloud environments, and virtualization help to homogeneity all the VMs. But this is a challenge for security issues because it's difficult to provide the same level of security services with the same resources for all the users' necessities. And you have a client with, I don't know, for example, a bank. You cannot offer the virtual machines that some student it's in a he's doing his homework, so there is not the same amount of resources, not only for the business logic, it's also provided by for the usage of the security implemented for the necessity of the user. And security and privacy challenges. Cloud computing is a multi-domain environment, and each domain can use different security and privacy requirements. So IDM, it's a identity management. Is the organizational process for ensuring individuals have the appropriate access to technology resources. And for example, the keys are one of the many steps in IDM process, but they are critical and a very common issue, and many companies are getting together to bring a solution to get rid of the rudimentary passwords using biometrics in our devices. This is a reference for the Apple previous software release. This is the WWDC of the current year, and they are releasing for in the subsequent months a feature for all the Apple devices in which you are getting rid of the passwords and the keys of your accounts. So you can share those credentials with other not Mac or not Apple users, but it's an innovative way of get rid of the same problem as forever. The keys are easy to forget, are easy to share, and biometrics are as Maddie says previous, it's a patch for another problem, because it's not solves everyone problem, but is easier to for the final user to use it. So there are different providers of identity management. There are a lot of frameworks, and they are very secure, and there are many providers. Access control and accounting. It's like, for example, if you are logging in a page change to another window with the same domain, and the access control should be allowed. And for example, contrary case, and bank account could deny the access used by seconds of inactivity. So you need to configure access control and accounting to ensure the requirements of the applications. And privacy and data protection, it's a core issue. And data stored outside my organization, it's a big problem for all the companies. It's not the same that you share a picture of your vacations in Google Cloud, and you are, for example, no publishing an embarrassing photo, but it's not the same that store all your company future patents of the new release product. So there is always a necessity for create the to have the mechanisms for privacy and data protections. And there are it's a concern for the provider that has that it's a concern for the provider to ensure that your privacy and data it's always protected. Organizational and security management. Security management life cycles models change when an organization adopt a cloud computer. So you need to start a dependency on external entities, and can also rise fears about for example, timely responses or delayed responses for security incidents. You don't have all the control in your organizations if you are using a cloud, but has some there is always benefits, because if you are, for example, a small company, the levels of security are not the same as, for example, AWS can provide, because has a monster company behind the service. And if you are, for example, a small company, you can't compare the level of security that you can provide for your application. And you need to restart your model business in the adapt the cloud computing. So you need to test, and you need to take again the risk analysis, the management processes, and penetration testing, and others methods for trust for your application security issues. And for the conclusions, to ensure cloud computing benefits, it is essential for providers and customers also rely on safe frameworks and standards, adopt newer and more mature solutions, and provide secure and private environments for widespread adoption. So you need to ensure that your developers in the cloud are using the more secure and the more the more secure the all the that security patches are applied for your instance, and all the provider part are accomplished, and you need to merge that how to say, you need to merge efforts in the customer and the provider for secure your application. So you cannot only depends on the provider side, and the provider cannot ensure the protection of your application if you are not doing the secure procedures on, or use the frameworks more secure and more well, all the more secure and the more the sorry, I forgot the word. And you sorry, I'm blocked. That's my conclusion for the paper. It's an effort for the provider and the customer. So I keep that in mind, and that will be all for my side. Yeah.
Okay, thank you, David. We can have a quick or short discussion answer to lead it by Brian.
Hello, everyone. Well, I prepared 3 questions, and well, the first one was reading the paper is at what level do you consider secure authentication methods? I mean, David explained about the method that Apple uses. So, are authentication methods secure? At what level are they secure? Or do you consider them secure?
I mean, I personally, I didn't totally get the question. I don't know, David, you or anyone else. You mean in what level authentication methods are secure?
Yeah.
I mean, like on a two-way, I think it's secure enough, right? Two-factor authentication. But yeah, it can be also hacked, right? It has been proven.
Well, I asked that because I consider it's not 100% secure, because, for example, old people, it's easy for them to forget the password to access, for example, the Google account. And for us, maybe it's kind of easier, but sometimes we need to click on forgot password, and we need to set a new one.
There is always a human factor in all the security concerns, but in the keys for leave it only for the and a password in a few letters or numbers. It's not. It's very easy to get the password if you are only using if you are not using the second how do you say it? The
Second factor?
yeah, the second factor.
I think Fernanda wants to say something.
Well, I don't know. I consider it was a good question because when he asked that, I also consider, okay, we never really like question like if there are other security ways to authenticate your information. And I asked because my husband studied security. And he told me, well, basically there are other alternatives are password rotation or ask the user to keep adding a new, I don't know, icon or not icon, sorry, a new element to the password that, but I think that will complicate the things for most of the users, as you said, also for people that old people.
I mean, about authentication, there are basically 4 ways to authenticate a person. Okay, asking them what they know. Okay, what they have, or what I mean, their belonging, what they know, what they have, who they are, what they do. Okay, so basically there are 4 ways, and then you, but what they know is like your passport, your secure question. That's what you know, right? What you have is your phone, your token that you generate. That's what belongs to you, what you have, what you carry with you. Then what you are, basically your fingerprint, your iris, your scan. Those are what you are, and what you do is the behavioral, basically, biometrics, like your voice, your signature, right? Your pattern of typing, your pattern of moving the mouse. So basically, multi-factor authentication is a combination of these four general ways, and there can't be literally any other way. So it says you should combine this. So multi-factor is like what you know, your password, what you have, your phone. So you can receive the SMS code. You can generate the token. So, or then you can add what you are, like your fingerprint, right? The scanning of your face.
But even those things change. I mean, even biometrical security systems change. What happened if one day I cut my finger, or I burn my face? I mean, or the voice changed sometimes.
Yeah, so exactly. These four different characters and 4 different options, and come up with different method of authentication. But personally, I don't see anything out of these 4. Personally, I don't know if someone else has any amazing idea that is not one of these 4. I mean, it doesn't go under one of these 4 categories. But what you were talking, Fernanda, is correct. I mean, that's why they force you to change your password once in a while. They force you to put certain number of characters. You just make it harder and harder and harder to basically for authentication to go wrong.
Yeah, and then we have like a different things that we need to log in, and then you need to remember everything, because sometimes they say that you can like use the same password in all the applications or on all this kind of stuff. So it's getting harder and harder to try to remembering all these kind of passwords, just because, well, you cannot have like a one universal password, right? So
you can actually.
Yeah, but you have that one.
You can do that. Like Bitwarden and LastPass. Bitwarden is the better one.
Yeah.
Which one? Can you repeat it?
Bitwarden. I write it.
Yeah, please.
I used to use LastPass for many years, but I don't like it anymore. They make it. You can just use.
They just had a leak. The last.
Yeah, that's what I want to say. that's what I wanted to say. If someone for some reason can hack that application, then everyone is going to be in some big problem, right?
True. But there is no way. I mean, there is no 100% security, and never be. So we should deal with that. I don't know. Maybe in future. I mean, that was a bad statement from me. Who knows what happens in the future? Any other question or thing to discuss?
Well, according to Cloud, I have a question. While reading the paper, they mentioned a lot of authentication methods, and I said, what are the new authentication measurements, and which provider proposed them? Because they mentioned something that AIM, something like that. And I said, okay, when I see my colleagues, I don't know, log into, I don't know, AWS, they use the username password, and I said, this is not like the most secure way. If somebody leaves the company and uses and tries to use a password or a user and password, they can log in and do whatever they want in the company, so they can access easily. There's there new measures.
So which is the question, sorry?
If there are new authentication methods when you try to access the cloud services?
Well, cloud services. Well, there are some things that companies are like doing. Like, for example, in Oracle, you cannot access nothing if you are not in the VPN, unless they want to do to let you do that from other parts. But most of the things that we are using in our cloud cannot be accessed if we are not into our VPN. You know, even if they have password, we need to first log into the VPN, and then we can access those. We can reach those pages.
I've seen some people in like telecommunications specialties that they use always hardware key. So for example, my girlfriend uses like her own ID. He has to connect it into her computer, and then he can access the extra codes. Otherwise, she can't. I mean, she does. I mean, and if she doesn't have the card, she can't get into the VPN. And if she doesn't get into the VPN, then yeah.
Yeah, it's the same thing. I mean, basically, you add extra layer, but what you carry, basically, now you have to carry always that hardware key, basically. Okay. Thanks. We can maybe wrap this up. Thank you so much, David, Brian, and everyone else for the discussion. Before we finish, I want to borrow your time for 5 minutes, okay? And I want to tell you about a little bit totally out of the context, out of the class. It's nothing related to class topic, but I want to talk to you about what's going on in Iran currently, okay? So because maybe I'm guessing you might hear something in the news, so I want you hear firsthand from me exactly what's going on, okay? So it's just quickly, I want to tell you what's happening, okay? So, and it's not so unrelated, okay, as you can see. Anonymous started hacking Iranian governments. It's basically websites, okay? Basically what they did, they started this Operation Iran things, and they start attacking basically a lot of government websites. And why they were doing that, it was basically, as I said, they initiated this program, and they warned that they're gonna mess up with Iranian, basically with governmental website. So I wanna tell you what's going on, okay? So what happened actually was this thing that I put in the center. So a 22 years old Iranian woman died, after being severely beaten by morality police over hijab law. So what is hijab is what basically the hijab is what the manner of covering themselves for women. Okay, I mean, what I'm telling you is like it's coming out of like history books or like weird stories, but it's real. I mean, the people are living like this. So there is a dress code that women should follow. And if they don't follow that, we have morality police. So it's a special police that check their dress code. And if they are not following that, so they can get fined. If they repeat, they can get into jail even. So they capture her one day in the street, okay, because she wasn't wearing, according to the law. After 1, 2, 3 hours, they basically transfer her body to the hospital in coma. And she dies after 2 days, okay? So there is an unrest in Iran currently last 5 days in most of the cities all over the country against this brutality of the regime. And as you can see, then it start getting really, even start attracting the attention of even celebrities, okay, that they don't really mind this type of thing. As you can see, Dua Lipa start publishing about it. Javi, the guy that does this, they started talking about it. So a lot of like celebrities started basically highlighting the problem of these things. So I thought maybe you hear about it. So I put the hashtag here, it's like Mahsa Amini, that's her name actually. So it's a weird things happening in Iran, okay. I know it's nothing related to the class, of course, just I thought you have to hear it firsthand and know exactly what's going on. I know it's a super far country, kind of insignificant nowadays, so but sometimes you say like, who cares, you know? That's why really you don't hear it much in the news. But anyway, I thought I need to share a little bit about this, okay, as a pink Iranian. Why not hearing from me firsthand? So it's a weird thing happening, like all this hijab thing, morality. Of course, people are sick of it. People want a total change. That's why there is unrest. Actually, this Anonymous, they put down the largest Iranian media site. They put down the central bank website. Then from yesterday, actually, the internet is shut down in Iran. So it's super hard now to have access. So actually the weird thing is happening is they are able to shut down the whole country's internet. And they did that before, but now they are just getting more able by help of China actually, okay, by the technology that they get from China, they can shut down the whole internet. And yeah, that's what's happening. I think what I read so far today, officially 30 people died in the street because they started, because when people are demonstrating, protesting, government just come out with the iron fist. There is no joke about it. They start shooting people in the street, and so far, okay, 30 people are officially dead. So probably there would be more. I mean, when the connection comes back, when the videos are released. So yeah, that's it. Just a little bit social political class. Okay. So I don't know if any question. If not, we can end this session.
Yeah, I read that note yesterday, and I also shared with my girlfriend, and we were talking about that kind of restrictions and how is like in these days nowadays this kind of rules are being.
I mean, sometimes I talk to my friend about this, and I mean, what I understand, they can't comprehend. I mean, because it's like you're reading, you know, a novel from George Orwell. It's a reality, you know. It's like unbelievable. Like in 2022, people or women still getting beaten, getting basically killed just because how they wear, what they wear. It's unbelievable. It's like, but I mean, but that's what's happened, and hopefully one day the change will come. Hopefully.
I hope this is a change for good for that country. I mean,
Yeah.
I have read they are already burning those hijab. They are like doing these protests, like
Yeah,
burning
yeah.
this-
So women are coming out there basically burning because it's not that they want this; it's they have to. Okay, so it's not a choice. Okay, I mean, I hope you understand. It's not a choice of the people.
Yes.
It's totally forced. Even like you, I mean, a woman, like Christian woman or whatever from outside of the country who travels to Iran as a tourist, they have to cover. It's crazy. They have to cover. It's like it's a force for everyone.
Yeah, the thing is that sometimes it's hard for us to make an opinion because we don't really know how the culture of the country is and even the religion, and sometimes you don't want to mess with people because you don't know, right? Yeah, but definitely killing someone because of the belief or something like that is not okay, and I hope that this make a big change in Iran, and
Yeah, I hope so.
it
Yeah,
brings
that's
the
honestly
best
that's
for
what
all the people living
I
there.
decided. Thanks. I decided to talk to you to make people understand at least small changes. Maybe this can propagate further. You know that this is absolute suppression. There isn't. It doesn't have anything to do with what people want. So the hijab, the covering, it's total suppression, and there is no freedom, no choice on it. Okay, so
Yeah.
It's too late already. So have a good night, everyone. See you guys. I updated the Google Sheet. Okay, so you can see the papers for the next week and next week. But for the second part, I haven't, but I'll update it soon.
Okay, thank you, Mari.
Okay, take care, guys. Stay safe.
Have a good weekend. Bye.
Have a good night.
Good night. Good night. Bye bye.
Thank you. You too.
Bye, thank you.